Hello learners, welcome to this course on Embedded System Design using PIC16F877 microcontroller. In this tutorial, I will be discussing about on how to use timers or counters, how to configure it and how to program the timers or counters. So timer is used for measuring specific time intervals. It is used to create time delays. So in order to use a timer, we have to use the clock source. So if we connect a 20 MHz crystal to a microcontroller, it is internally divided by 4. So that frequency, 1/4th frequency, will be used as a default timing interval. A counter, the same hardware, can be used as a counter. It is used for measuring the events or counting the events. So here the event occurrence is through an external mode. So this timer or counter is a hardware based timer or counters. So it is more accurate when compared to your software based timer or counters. So here in PIC16F877 microcontroller, we have 3 timer or counter modules. So the name is timer 0, timer 1, timer 2. So timer 0 is a 8-bit timer or counter. Timer 1 is a 16-bit timer or counter. Timer 2 can be only used as a 8-bit timer. So in this tutorial, I will be describing about timer 0. So the same hardware can be used as a timer and also as a counter. So timer, in the sense, the clock source is going to be an internal clock source which is going to increment the timer register, whereas in case of a counter, an external event will try to increment the timer register. So here we see the block diagram representation of a timer 0. So where I have F oscillator by 4 is used in a timer mode. So this pulses will be given for the incrementing the timer 0 register. Since timer 0 is a 8-bit timer or counter, so this timer 0 is a 8-bit register. So we can load some value into this timer 0 register and the incrementation of the value can happen depending upon this F oscillator by 4 clock frequency. So then such a mode is called as a timer mode. So if I use an external event, so the external event can be connected to this T0 CKI pin. So T0 CKI is timer 0 clock input pin. So any event occurred on this pin can be used for incrementing this timer 0 register content. So in order to get this value, we have to select whether we are going to operate this timer in a timer mode or a counter mode. For that we have a bit called as T0CS. So T0CS is a timer 0 clock source. So later I will discuss about that bit. Thereby a timer mode or counter mode will be enabled. And there is also a prescaler. So this prescaler can be used for adjusting this clock frequency. Either it is an internal or external, we can adjust the clock frequency by using this prescaler register. So for example, if my prescaler register content is 2, then in timer mode, our frequency is going to be F oscillator by 4. So this frequency is further divided by 2. So thereby it becomes F oscillator by 8. And at that rate, the timer 0 register will be incremented. So let us consider a simple example. This is a timer 0 register, 8-bit register. So we can load a value onto this timer 0 register. So let us assume I am going to put 8 zeros into this timer 0 register. And when a first clock pulse comes, the value will get incremented to 701. During the next clock pulse, it becomes 10, then 11. 100, 101, 110, 111. So like that it keeps on going. When I have 255th clock, I will get 1 1 1 1 1 1 1 1. So 8 ones will be there. The subsequent clock pulse, 256th clock pulse, will overflow this timer register because the value exceeds a 8-bit value, so it becomes 8 zeros, and this condition causes a timer 0 interrupt. So this interrupt can be used for activating your peripheral devices, which is called as a timer 0 interrupt. So the clock frequency, at what rate the incrementation should happen, that can be changed with the help of a prescaler here. So by default, I can use this F oscillator by 4 frequency with a prescaler value. Default value is 2. So we have a clock frequency of about F oscillator by 8, which is a default value for our incrementation frequency. So this frequency can be altered by putting different values in the prescaler register. Instead of 2, I can put 4, 8, 16, 32. So depending upon that value, this clock frequency will get modified. Thereby the incrementation frequency also is going to change. If the incrementation frequency is changing, automatically the time of incrementation is also going to get varied. Let us do some simple calculation. So let us take a clock frequency of 20 MHz connected to our microcontroller. So it is internally divided by 4, it becomes 5 MHz. So the time period for this clock frequency is 1 by F oscillator, which is equal to 0.2 microsecond. So this is for one clock period. So let us assume we are not going to put any values into this prescaler. So let us assume it is having 1. In that case, after 256th clock period, for each clock period 0.2 microsecond. So in order for the timer 0 to overflow, I require 256 clock pulses. So I multiply it 0.2 microsecond into 256, it comes about to be 51.2 microsecond. So after 51.2 microsecond, the timer 0 interrupt will be generated. This is the condition when I put an initial value of 8 zeros. If I change the initial value to some other value, then automatically this time period can change. So by changing the initial value, I can modify this time period. By changing the prescaler value, I can modify this time period. So we need to do configuration of this timer module, then only we can use it in our application. For that we have two important registers. One is Intercon Register and another one is Option Register. First let me talk about this Option Register. So in this Option Register, I have a bit called as T0CS. So this T0CS is a timer 0 clock source. Whether the timer is going to be used as a timer mode or a counter mode, that is decided by this T0CS. If this T0CS bit is set to 1, then it will be configured as counter mode. If it is 0, it will be configured as timer mode. Then I have a PSA. PSA is a prescaler. So here I have discussed about this prescaler. This prescaler register is common for both your timer 0 register and a watchdog timer. So I have to select it, whether I want to use this prescaler register for timer 0 or I want to use it for watchdog timer. So in order to do that, I use this PSA. If PSA is equal to 1, then the prescaler register is assigned to watchdog timer. If it is 0, it is assigned to timer 0 register. Then I have this 3 bits PS2, PS1, PS0. This determines the rate at which our incrementation happens. If I put a value, so here I show a table of PS2, PS1, PS0. If it is 0, 0, 0, then the timer 0 rate will be 1:2. 1:2 in the sense, when I connect a 20 MHz crystal, it is internally divided by 4, it becomes 5 MHz. And this 5 MHz is also divided by 2. Since it is 1:2 rate, it will be divided by 2. So it becomes 2.5 MHz. So at 2.5 MHz speed, the incrementation will happen in the timer 0 register. Same way I can change the incrementation frequency. So by changing the incrementation frequency, so if it is 1:4, which means F oscillator by 4 divided by 4, it becomes F oscillator by 16. So at this rate, the incrementation will happen. Same case, if I go with 1:256, what happens? F oscillator by 4 divided by 256, so it becomes F oscillator by 1024. So at that frequency, the incrementation will happen. So if my frequency reduces, as I go down, what happens? The frequency is reducing. So the incrementation time period gets increased. As the frequency is reducing, incrementation time period will get increased. So thereby I can change the time period between the incrementation of the timer 0 register. So by changing this, I can have the interrupt generation can also be altered with different time frames. So now in this example, what I am going to do is I am going to toggle an LED for every 1 second using timer 0 register. Previously we have done the same thing using software delay. So we used a function called as delay underscore ms 1000, which means it will create a delay of 1 second, which is a software based delay. Now we are going to generate the same delay, 1 second delay, now using a hardware timer 0. So I am going to take a microcontroller, PIC16F877 microcontroller, connect an LED to RB0 pin, and I want to toggle this LED, toggling in the sense changing the state. I want to toggle this LED for every 1 second. Now let us do a simple calculation. If I take a crystal frequency of 20 MHz, if my pre-scalar value PS2, PS1, PS0 is set with 0, 0, 0, then it is 1:2 rate. So timer 0 rate is 1:2. Then for single incrementation to happen, single incrementation in the sense, if this is the initial value, in order to get the subsequent 7 zeros 1, the single incrementation value, let us calculate 20 MHz divided by 4. Since it is 1:2, I divide it by 2, so it becomes 2.5 MHz. So the time period is around 0.4 microsecond. So it takes 0.4 microsecond to change from 8 zeros to 701. If I want to do this operation for 256 times, then I need to multiply this. I need to multiply this 0.4 microsecond into 256. So thereby 102.4 microseconds it will take for the timer to overflow. So this is for one overflow. For the timer to overflow once, I require a time period of 102.4 microseconds. So in 1 second, how much such overflows I require? So for example, 1 second in the sense 1000 millisecond. For 1 second, how many times my timer should overflow? 1000 millisecond divided by 102.4 microsecond, which comes about to be 9766. So my timer should overflow 9766 times, then only 1 second has occurred. When 1 second occurred, I can toggle the LED. After 9766 counts, I can toggle the LED, change the state of the LED. So this is a simple calculation required to do our programming part. Just remember this value 9766. So this we will try to use it in our program. Now let us go and build the circuit in Proteus environment. So here I have taken a PIC16F877 microcontroller. It is connected with a 20 MHz crystal with 33 picofarad capacitors, and the memory clear pin is connected with the reset circuit. So by default, this pin will be at logic high. Whenever I close the switch, it will go to 0, thereby reset condition occurs. Then I have connected a LED, blue LED to RB0 pin. Anode is connected to your RB0 pin, cathode of LED is connected to ground. So this is a simple circuit diagram. So now let us go and discuss the program, which we have built using Micro C Pro for PIC compiler. So here I have selected the IC to be PIC16F877 microcontroller, and the oscillator frequency is 20 MHz. So in the main program, first I need to do the configuration of the timer. So for that I put option register equal to 0x 80. So 0x80 means it is, so 0x80, 80 means 1, 0, 0, all 7 zeros, 1, all 7 zeros. So this 2 bits we don't require. This T0CS I am setting it to 0, which means I am configuring it as in a timer mode. Then PSA also I am setting it to 0, which means prescaler is assigned to timer 0 register. And 000 means I am setting the timer 0 rate to be 1:2. So that is the configuration which we do for option register. So thereby I set a value 0x80 here. Next is Intercon register. So Intercon register we set it with A0. A0 in the sense 1, 0, 1, 0, all 4 zeros. Lower part is 4 zeros. So 1 global interrupt enable. So this is required for enabling all the interrupts, and I am enabling the timer 0 interrupt. So timer 0 interrupt enable. T0IE is timer 0 interrupt enable. So this is global interrupt enable for enabling all the interrupts, and this is a specialized switch for your timer 0 interrupt. And I am resetting the timer 0 flag also. Timer 0 IF flag. Whenever a timer 0 interrupt is generated, the flag will be set automatically. Once the interrupt is being serviced, we need to reset this flag. So the flag will be generated on an interrupt occurrence. After the interrupt being serviced, the flag should be reset. So we set a value of A0 to the Intercon register. So Intercon register is set with 0x80, and I am going to use port B to connect your LED. So I am configuring the port B as an output port. So setting a value of 0 to TRISB register will make the port to be an output port. Then I am initializing that value to be 0. So the LED will be in off state, and in a while loop I am going to keep on running here. So now we have switched on the interrupt. The timer starts incrementing. When it overflows, an interrupt will be generated. So when an interrupt gets generated, it goes into this ISR. So this is your ISR. Void interrupt is your ISR. So here once an interrupt is generated, it goes into the ISR. Inside the ISR, first thing we have to do is we have to check which interrupt has occurred. For that we make use of this T0IF flag. So this T0IF flag, it is available in the Intercon register. So this will be automatically set when an overflow has occurred. So we try to check whether the timer 0 interrupt has occurred. So that is checked using intercon.T0IF equal to 1. If that is the case, I increment a variable, timer count. First initially I have initialized it to 0, so now it becomes 1. Then I reset the flag, timer 0 interrupt flag. Then I am checking whether my timer count has reached 9766. No, it is just for one time, right? So this if condition will not get executed, it will come out. Again it will run in the while loop. So again when the timer overflows for the second time, again it goes into the interrupt, check for the interrupt. If it is a timer 0 interrupt, increment the value. Then again reset the flag, check for the condition. Like that it keeps on continuing. When my timer overflows for 9766th time, at that time what we do, this condition will be executed. When my timer count is equal to 9766th time, the timer has overflown. At that time we just change the logic of the port B F0 pin. So this not indicates it's a ones complement. If it is 0, it becomes 1. 1 means it becomes 0. So we just toggle the state of port B 0th pin. So this port B 0th pin is connected to your LED. So the LED will start toggling. Then I initialize the timer count again to 0. Again it keeps on incrementing. When the count value becomes 9766, again the toggling will take place. So like this program is going to continuously run. Thereby we create a toggling of LED using timer 0. So after writing this program, we need to build the program. So we just execute the program. So it gets compiled. Now let us go to the circuit, import that program file, edit properties, select that. So this is a LED underscore timer 0 X file, import it into the microcontroller, set the clock frequency to be 20 megahertz, press OK. So now let us check whether our program works fine. So just press this play button. You can see the LED toggles for every 1 second. So now this toggling happens with the help of a hardware timer. It is not a software timer, it's a hardware timer. Using timer 0, for every 1 second we started toggling our LED. So in this tutorial, I have described about how to do a toggling of LED for every 1 second using timer 0 register. Thanks for watching. Please subscribe for more technical learning. Thank you.